Welcome to another episode of Environmental Digest. Today, we are going to talk about a hidden source of clean energy right under our feet and our tires. What if the roads we drive on every single day could actually power our world? In this explainer, we're digging into the science of power from pavement, a technology that could turn all that traffic into a source of clean energy.
Just think about that question for a second. What if the constant rumble of traffic, something we barely even notice, wasn't just noise and vibration? What if it was a source of clean, renewable energy? Let's dive into how our roads could literally become power plants.
You have to understand the scale of this. In the United States alone, we're talking about over 6.4 million kilometers of road. Every single day, countless vehicles are pressing down on this pavement, creating this immense amount of kinetic and mechanical energy that just dissipates. It turns into a little bit of heat, a little bit of vibration, and then it's gone. It's a colossal amount of untapped potential.
So, the big question is, how do we actually capture this energy? Well, the secret isn't in some big, bulky engine or a spinning turbine. Nope, it's something that could be embedded right inside the road itself, all thanks to a really remarkable scientific principle.
And this right here is the key. It's called the piezoelectric effect. Now I know, it sounds super complex, but the basic idea is actually pretty simple. Imagine squeezing a special kind of crystal and having it produce a tiny spark of electricity. That's pretty much what piezoelectricity is. Certain materials, when you stress them or squeeze them or vibrate them, they generate an electric charge. To make this all work, engineers are looking at a few different types of these piezoelectric materials. You've got some that are rigid, kind of like a ceramic, which are great for embedding into something solid, like concrete. But then you have others that are more like a flexible film, designed to bend and move with the road. Each one has its own strengths, depending on where you're going to use it.
But you can't just sprinkle this stuff into the asphalt like salt. It has to be packaged into these really cleverly engineered devices called transducers. And here are a few of the designs people are working with. Some, like the symbol design, flex under pressure, while others get compressed. Each one is basically a tiny generator, designed to take the force of a car passing over and turn it into a little pulse of electricity.
So you should know, this isn't just some theory stuck in a lab. Researchers have been developing and testing these systems for years now. Let's take a look at how this technology has evolved and what it can actually do out in the real world.
Believe it or not, this idea has been building for 2 decades. It really kicked off with some early feasibility studies way back in 2004. By the late 2000s, people were getting serious about actually embedding these things in pavement. And fast forward to more recently, studies have shown these systems can generate enough power for some really practical uses, like lighting up the LED strips that guide traffic at night.
So how much power are we really talking about here? Is it a lot? Well, a study at Macquarie University projected that piezoelectric tiles in a really high-traffic pedestrian area could generate 1.1 megawatt-hours a year. To give you some context, that's enough to power an average Australian home for about 2 months.
And get this, another study at Kuala Lumpur International Airport figured that just by placing 1,000 of these tiles in a busy spot, they could harvest over 130 kilowatt-hours every single day. That's enough juice to keep 26 light bulbs running, non-stop, for an entire month. So here's the crucial takeaway. Experts don't really see this technology replacing massive solar farms or wind turbines anytime soon. Instead, they see it as a really powerful supplementary source. It's perfect for powering the infrastructure right there on the road, things like traffic lights, road sensors, digital signs, or emergency call boxes, powering them directly from the energy of the traffic itself.
Okay, but if this technology is so promising, why isn't every new road we build a power plant? Well, like with any cool new technology, there are some pretty significant hurdles that we need to get over first.
All right, here's the reality check. The installation costs are still really high, and there are huge questions about durability. How long can these sensitive electronics actually last while being pounded by millions of tons of steel every year? This isn't just a simple materials problem, it's a huge challenge of putting delicate tech into one of the harshest environments you can imagine. Plus, the energy output can be inconsistent, and figuring out how to store and transfer that power efficiently is another big technical puzzle.
And here is one of the most fascinating challenges of all. The very process of building a road could destroy the technology. Hot asphalt is laid at temperatures that can get up to 250 degrees Celsius. The problem is, that heat is dangerously close to the Curie temperature of these materials. That's the point of no return, where they permanently lose their ability to generate electricity. It's like trying to bake a cake with an ice cream filling.
This chart really puts that challenge into perspective. Power density is basically how much energy you can get from a certain area. And right now, you can see piezoelectric tech's output is lower than solar or even thermoelectric methods. Now, this doesn't mean it's not useful, but it does mean it has to be used strategically, in places with constant, heavy pressure that can make up for that lower efficiency.
But listen, these roadblocks aren't the end of the story, not at all. In fact, they're the very things that are driving the next wave of innovation in this whole field. So what's the path forward? Well, researchers are tackling this from all sides. They're working on developing new materials that are tougher and more resilient. They're designing more efficient transducers to capture more energy from every impact. And maybe most importantly, they're exploring hybrid systems. And of course, they're doing the hard economic math to figure out where this technology actually makes financial sense.
And this, right here, is probably the most promising path forward. Imagine a smart road that doesn't just rely on one source of energy. It could have these piezoelectric generators under the pavement, sure, but it could also have solar panels on the noise barriers along the highway, maybe even thermoelectric devices that create power from the temperature difference between the hot road and the cooler ground underneath. This kind of hybrid approach creates a much more consistent and reliable source of power.
And that really brings us to the bigger picture here. We're not just talking about generating a little bit of electricity, we're talking about completely redefining what a road even is.
Will our infrastructure become an active, breathing part of our energy grid? Look, the technology faces some very real challenges. There's no doubt about it. But the potential is just undeniable. It forces us to look at the world around us not just as something to move through, but as a source of clean, sustainable energy that's just waiting to be unlocked.